In this video, I'll show you how to run a YOLO model optimized for your Raspberry. In a previous video, I've shown how to use Ultralytics library on Raspberry for object detection. Now we will see how it is possible to optimize it with a small change. Let's imagine you've spent hours training the perfect PyTorch model. It's accurate, it's fast, and it works great on your workstation. But now, you want to put it into the real world. For instance, you would like to run it on a Raspberry. Installing the whole PyTorch library, it's overkill. This is where ONNX, the Open Neural Network Exchange, becomes your best friend. Think of ONNX as a universal translator for AI. It takes your complex PyTorch graph and flattens it into a high-performance format that doesn't care about your original framework. When we move to the Raspberry, we aren't going to use PyTorch at all. We're going to use the ONNX Runtime. It's lightweight, it's designed for the edge, and it's going to give your Raspberry the performance boost it deserves. Let's dive deep into the code. The first step is to export the YOLO model to ONNX format. Thanks to Ultralytics library, it is possible to export easily. Let's quickly explain the code. Opset equals 12. Opset stands for operator set. Think of this as the version of the ONNX dictionary. Simplify equals true. This is arguably the most important argument for a Raspberry user. It has a double function. When a model is exported, it often contains junk nodes, redundant mathematical operations that don't change the output but slow down the processor. Setting this to true runs the ONNX simplifier tool. It fuses constant layers and prunes the graph, resulting in a faster, leaner model file that is much easier for the Raspberry's CPU to digest. Let's now export our model. On my side, I'm working directly on my Raspberry, but for instance, you could also export the model on your workstation and then move on your Raspberry. Once we have our .onx model, we can run a code for doing object detection. First of all, let's explain the main part of the code. We need to import ONNX Runtime. It will allow us to run our AI model. I've written a simple class that contains the post-processing methods as well as the detection part. The constructor sets two parameters called conf and iou that are the confidence threshold and the intersection over union. Ort.inference session is the most important line. Instead of loading PyTorch, we are using ONNX Runtime. This loads the model into memory and prepares the mathematical graph for execution. With CPU execution provider, you are explicitly telling the model to run on the ARM CPU. It's highly optimized for this. This helps to improve performances because Raspberry usually doesn't have a dedicated NVIDIA GPU. We define also a list with the objects classes that can be detected by the model. The call method contains the whole logic of the model. It first converts the input image in the range 0 to 1. We transpose the image from height, width, channel to channel, height, width, and add batch dimension. Once the image is ready, we can run ONNX Runtime. Once we have the detections, we can post-process them. For the post-processing, the main steps are transposing back the input, extracting boxes and scores, getting classes ID and confidences. Only predictions with a confidence larger than the defined threshold will be accepted. Scaling back to the original size. Applying non-maximum suppression. We're actually going to look to overlapping boxes and keep only the best one. Finally, we create a dictionary with the results. I've also defined an extra function to help plot the results for each frame. If now we go to the main workflow, it is really easy. We start the PI camera and wait a few seconds to work up it. We define the format RGB 888. It actually indicated the 3 channels red, green, blue, and a bit depth of 8 bits for each of them. In order to have a continuous live detection, we can define a while loop that will, in order, capture an image, run detections on it, plot and show the results. It finally wait 1 milliseconds before restarting the loop to allow to render the image. As exit condition, the user can press Q key. If we exit the for loop, we stop the PI camera and destroy all active windows. Let's now run our script and wait a few seconds. We can observe that the model is able to recognize the objects in its view. It was all for this video. We have learned how to export a model to ONNX format and run a resource-intensive model on a low-power device for object detections. I hope you've enjoyed this video. See you soon in the next one.